Now let us continue the discussion and see more about the Selflike commands, command syntax, okay, and all those things in today's session.
Hey Murali, this is Sai.
Yeah, Sai.
Quick question, we go further. I'm not really sure how many of other students have tried logging into the VM, but for some reason, since morning, I'm trying to get into it. Is either aborting after 1 or 2 minutes, and the commands are getting taken very delay in the VMs. And I don't have any internet issues because my internet is 200 Mbps.
Okay. Yeah, in fact, Ram also reported this before the session. Okay, so let me check what is happening. See, sometimes I know this. See, first of all, in fact, I should set this expectation. The lab will be little bit slow. The systems will be little bit slow because we are using the desktop systems, and on that we have installed 5 virtual machines. Okay, so Exadata is a heavy load, and mainly more than memory, it is I/O. Okay, because in the lab we have one physical disk. So all the servers, all the I/O is hitting the single disk. Okay, definitely compared to your project systems, okay, you might see a delayed response, but it's not that bad. Okay, it is manageable, but sometimes it will be little bit okay, headache. I know this, and mainly I will tell you, your internet speed may be high, but because we are coming over the internet, it all depends on the traffic conditions also sometimes. For example, I will say many times I also face this. If I connect during night time, it will be very faster. But during peak hours, India peak hours, say evening 6 o'clock, that time I see very slow response. Okay, so that is another reason. The third reason could be really there could be some problem in the lab. Okay, the system may be very slow. In that case also you will experience that. Okay, so let me see what exactly is the issue now. Okay, yeah, that's fine. Yeah. Then your system should be able to give you that expected performance, and it should be able to support all the Exadata VMs. Okay. Let me check after this class. Immediately I will check in front of you only and see whether the system has any problem. Okay. Or see, when the system is very slow also, you experience that. It will connect, but immediately within 1 or 2 minutes your connection will be lost. Again you have to connect. So that is also one of the observed issue. And these systems are running for okay, a longer time. Okay, let me see what is happening. Okay, maybe it is temporary issue. We'll fix that. Okay. So today let us see more about Selflike commands. Now this slide shows you the command syntax. Selflike has 2 types of commands: admin command, object command. Okay, and if you are typing object command, you have to mention the object name. As I discussed yesterday, like database has database objects, cell has cell objects. All the object commands are executed on objects. Okay, so that way admin command or object command with object name. Then optionally you can mention options. Okay, so admin command is the admin command, administrative command, and object command is action performed on an object, and object is okay the Selflike object on which the command has to be performed. And you can include options to filter the results, okay? Like Linux commands has options, right? So here also you have the options. Some rules around Selflike commands. Commands and objects and options are not case sensitive except when enclosed in quotation marks. So it is similar to SQL commands. They are not case sensitive, but when you enclose in quotes, they are case sensitive. And when it comes to quotes, you can use single quotes or double quotes. Either one is fine. And the commands are always executed on the cell to which you are connected, local cell. And command can be terminated with semicolon, but semicolon is optional. And command can be continued on the second line by using hyphen symbol at the end of the first line. So if you are typing a big command which is wrapping to the second line, so you have to end the first line with hyphen command, otherwise the command will be executed immediately. Okay. And Selflike also supports command line history editing, similar to the modern shells like Bash. So you don't need to type previous command. You can just use arrow buttons to scroll through the previous commands, and you can use cursor to edit the commands. So this slide shows you the two categories of Selflike commands and the Selflike objects. Selflike has admin commands and object commands. Admin commands are like your SQL plus commands like exit, help, quit, set, spool, start. Okay, so these are not really useful commands maybe. Okay, like your SQL plus formatting commands. Then the main commands are object commands. You have create command, you have alter command, you have describe command, drop command, export, grant. Okay, there are many commands under this category. And when you execute object commands, these commands requires you to mention object. Selflike has different objects. So this slide shows you some of the important objects. Okay, so all the object commands requires you to specify the object. As mentioned in this slide. Some of the objects, cell is an object, cell disk is an object, okay? Then grid disk is an object, flash cache is an object, okay? So like that, there are many objects which you can mention in the commands. Then, every object has attributes, okay, which are assigned when the object is created or altered. Okay, you can list the attributes using describe command. Okay, and not only that, it will show you which attributes can be modifiable user, which attributes cannot be modifiable by the user. Okay, so you can use attribute filters, okay, in list command to list the results as per your specific requirements. Okay, we'll see this. For example, this slide shows you describe command on an object called cell disk. Cell disk is an object, so we are using describe command. So it is showing the attributes like name, comment, creation time, device name, okay, like that. These are the attributes. And in the next column, it is showing you which attributes can be modifiable. Okay, so out of all these attributes, you can modify only name and the comment. Other attributes are fixed, you cannot modify them. So like that, for every object, you can use the describe command to see the attributes and to understand which attributes can be modifiable. Then you can use a list command to display the attributes and their current values. Okay, and the list is the most commonly used command during the initial practices. So this slide shows you how to use a list command, okay, on various objects. List cell. Cell is an object. So for that cell, it will show you all the attributes and their current settings. Then cell disk, okay, is an attribute. Physical disk is an attribute. Okay. And for anything, if you want a detailed display, you can say detail at the end of the object. Okay, like list cell detail, list physical disk detail, like that. And in list command, this is the syntax of the list command. You can use where clause to filter the results also. Like list learn where disk type equal to hard disk. List learn or list cell disk where disk type equal to flash disk. Okay, so you can use where clause in list command to filter the results. Then Selflike has reserved words. This slide shows you all the reserved words. So if these reserved words are used in commands, they must be enclosed in quotation marks. Okay. So that is about Selflike commands, the syntax, the rules around the commands, and the reserved words. Now, next utility is declare. Declare, distributed command line utility. Again, declare is also installed on every cell server, but before using declare, it needs some initial setup and configuration. Okay, so we have an exercise, we have a lab exercise to do that. Declare can be used to run commands on multiple cells. Okay, facilitates centralized management. So you can use a declare to execute the same command on multiple cells parallelly. Instead of logging into every cell and executing the command individually, you can configure declare, and from one of the node you can fire the command to execute this command on multiple cells. Declare can be used to run cell commands, okay, and not only cell commands, you can even run operating system commands with the declare, and you can even copy files with the declare. Okay, suppose on a real full rack machine you have 14 storage servers. Suppose you want to copy a file to all the 14 storage servers. Okay, you can use declare to copy this file. With one command, it will copy to all the storage servers. Instead of you connecting to every server individually and copying that file. Okay, 14 times. You can use declare. So declare supports more commands. It supports all the Selflike commands. Additionally, you can run operating system commands also, and you can copy files. So that way it is very useful for centralized management. This slide shows some examples of declare. Assuming that we have configured declare, the initial setup has been done, you can use declare to execute commands on multiple cells. So the first example shows you how to use declare to run list cell command, right, on these three cells, cell 1, cell 2, cell 3. So the syntax, if you see declare -c, so then you need to specify the cell names, each cell name separated with comma. Then Selflike command that you want to execute. Selflike-e, the command list cell. So it will show you the status of all the 3 cells now. This command will be executed on all the 3 cells, and the display will be shown to you immediately. The result will be shown to you. Then the second example uses a file called group file whose name is mycells. Instead of typing the cell name every time on the command line, you can create a group file, and this file will have the names of all the cells. And this group file can be passed on as an argument to the decline. So decline-g mycells. So again the same command, selflike-e list cell. Okay. So only difference between the first command and this command is, first command I am typing the cell names individually. Second command I am not typing the cell names. I am passing the file. This file has the cell names. Okay. Like in EXPDP, you have pair file. Instead of typing the export parameters on the command line every time, you can create a pair file, include the parameters in that file, and pass this pair file as an argument to your EXPDP or IMPDP. So it is similar to that. And the third command shows you how to execute operating system commands. So here I want to see whether all the storage servers, the time is synchronized or not, running the same time or not. So in real time you will have 14 storage servers. Instead of you connecting to every storage server individually and executing date command and checking the date and the time, you can use a decline from one of the cell and execute the command. So that way decline is very useful for centralized administration. From one cell you can execute commands on multiple cells. Okay, so let me show you few commands on the system now. Let me log in, and so that I can also check your issue. Yesterday I was a little bit busy. I could not spend the time on this thing. I'm also trying some different setup with SSD storage for faster access. So I will connect to Sai's server because you reported some issue. Let me check from my side. 130, right? Okay, so you have Xeon on your laptop, Sai? You tested this, or any of your friends has this?
Yeah. I have. My brother has a Mac Pro. It has Xeon E5.
Okay. Okay, but I don't know cost perspective. If it is single system, you can afford, but in the lab, I need many systems.
Right. But you can, if you go with the hexa-core with that, and you can host probably, 20 VMs, 20 to 30 VMs on it without any issue.
Maybe can you ping me that model or whatever? I will do some research on that.
Sure.
Or show me that website, the URL, wherever you can find those details. I will go through that.
Sure.
Okay. In fact, I am trying to purchase a new servers for Exadata. The current servers are saturated actually.
Okay.
New infrastructure I'm planning, but again I have to see budget also.
Yeah. Got it. I mean, this one I don't have any complaint. The only thing is, I know, that tells me busy because you generally quickly respond to my emails, right? So I did not see response. That means I thought you're busy.
Yeah,
All I
yesterday
want
I
instead
was.
friends so that, I can build on my own so that I don't need to, even use these, the
Yeah.
over the, yeah.
Okay. Yeah, do one thing. If you want to build on your own,
Yeah.
I would suggest, it is up to you, I would suggest you to do this after the course because it is very
Okay.
lengthy and a complicated process. Okay. And it might take long time. Okay. Maybe 1 week time or okay, 3-4 days time minimum. And you may get into different issues during the setup and the configuration. Okay. So it is
Yeah.
always advisable to do this after the course. By that time you will have more knowledge about the Exadata and you can easily troubleshoot and quickly set up that.
Yeah. No problem.
Okay. But it is up to you. If you want to, if you have time, you can do now.
Yeah. I mean, this is my passion. I build a lot of systems,
Mm.
especially in the virtual environment.
Yeah.
So that's it. Yeah.
Okay. No problem. Okay. So I am also facing the same issue. It is the system must be slow. Then who complained? RAM 115. Okay. Let me see. So if this is happening, the basic check that you can do, I'm sure everybody knows. Okay. First, try to ping to your IP. Okay. See the latency. Suppose 192.168.1.115. That will tell you a little bit more. 115. Okay. So it says a destination host unreachable. Maybe there is some network problem. Okay. First of all, it is not even pinging, so you cannot obviously SSH. But if you try to ping to Sai system 130, right? It is pinging, right? So that means you should be able to SSH now, and if you are disconnecting immediately, the system may be
Yeah.
experiencing a slowness. Okay.
Yeah. There is a issue. If you use the ping -t and
Yeah.
the IP address, it will break.
Yeah,
That's
yeah. In
something.
between, it will
Yeah.
show you timeout.
Yes. Yeah. That is what is happening.
So some packets may drop under timeout. Okay,
Yeah.
with extended statistics.
Yeah.
Yeah. So it's also not very stable, your system
Yeah.
connectivity.
First, I thought maybe you have some issues because of the rain. I heard a lot of rain right in
Yeah,
Hyderabad. So
I,
it's some.
you don't know. Okay. Anyway, my team will come now, 8 o'clock IST, 8 a.m. to 8 p.m. The support team is available, so I will ask them to see what is happening in the lab. Okay. But by far, we never had any major issues with the system connectivity or performance. Okay. It is manageable, though it is not very fast. It is reasonable and
Yeah. Yesterday it was fine. No issues. I mean, I checked, right? So only today there must be some issue.
right.
It is timing out.
Hmm.
So
Yeah.
yeah.
Just let me take few more minutes and see with other servers.
Sure.
110 is assigned to Praveen. At least if I can connect it to one server, I can show all these demos. 110. Hmm. So in fact, in the lab, some systems are connected to one switch, other systems are connected to a different switch. Sometimes switch level issues also will create these kind of issues. We may have to restart the switch because these switches are not the data center level kind of switches which need to be restarted every now and then.
Yeah.
Again, I got okay. So let us log into SSH to the storage server, one of the storage server. And start the Selflike. So you can simply type help. Okay, you will see get the online help and various commands. Okay, and if you want to get the help about a particular command, help list is a command. Initially, we'll be using list command very often. So it will show you the usage, the syntax of the list command. So that way you can get online help. Then you can use when it is okay, looks like this is problem with every system. Let me ping to my team.
Sure.
Okay, so I am sure you must have noted we have a support group. You can reach them over Skype. The Skype ID is euclid.support. You can reach them over mail. Again, the mail ID is euclid.support@euclidit.com. Okay. So any issues, such issues, you ping to them in the Skype or send a mail. And you can mail me also, but most of the time I may not be immediately looking into your issues because I am out of office. I will be somewhere else with the different things. Okay. So whenever I see, I will quickly respond, but always keep that to our support team. Send that to our support team. Yeah. Okay. So let us continue with the class in that case. Okay. Because otherwise we'll maybe wasting time like this with connectivity issues today. Now, next concept is storage concepts, Exadata storage concepts. Now you know Exadata uses two types of storage. One is the traditional hard disk based storage, then flash disk storage, which is your SSD. Okay. So starting from version 2, Exadata is using flash storage. In version 1, there was no flash storage, but from version 2, way back to 2009 onwards, flash storage is available in Exadata. So Oracle has reached to a stage where it is nowadays shipping storage servers entirely with flash storage. So those kind of storage servers are called as EF, Extreme Flash Storage Servers. Okay. And the other servers are called as high capacity storage servers, which has both hard disk storage as well as flash disk storage. So customers can choose between high capacity storage servers, which has hard disk storage as well as flash disk storage, or the second storage server is extreme flash storage server, which has only flash storage. Okay, so that is the concept. Now Exadata storage server uses various objects, right? These storage objects are primarily your physical disk object, flash disk, cell disk, grid disk, ASM disks. Okay, so these are the various storage objects used in Exadata, referred to in Exadata. So let us see what are these fundamental objects. You know, physical disk, it is the hard disk on the storage cell. Each storage server has 12 number of physical disks. Okay, all with the same capacity and same characteristics. So from version 1 till version 7, which is X6, each storage server has exactly 12 physical disks. 12 is fixed. And the difference is version to version, Oracle may include bigger disks. For example, in the latest version, which is X6, the disk capacity is 8 terabyte. Okay, because nowadays we are getting 8 terabyte disks. But if you go back to few years, at that time there were no 8 terabyte disks. So the older versions may support disks with less capacity, maybe 2 terabyte, okay, or 1 gigabyte or 1 terabyte, 500 GB disks like that. Okay, but the 12 is fixed. Next object is flash disk. So these flash disks are present only on the storage server, not on the database server. Okay, and these flash disks are attached as PCIe cards, not as the hard disks which are behind the controller. Okay, so they are directly attached to the system bus over PCIe slots. And again, each storage server has 16 flash disks or flash modules. Actually, there will be 4 slots on the board, and in each slot you will put one flash card, and each flash card has 4 flash modules. So 4 into 4 is total 16 flash modules will be there. Again, the difference is version to version, the flash module size will be varying, but the number is fixed in. Okay. Next, cell disk. So once you have physical hard disk and physical flash disks, there is some logical objects. There are some logical objects created on the physical objects. So there is some logical abstraction. So in this logical layer, you will have 2 more objects called cell disk and grid disks. So hard disk and flash disk are physical, cell disk and grid disks are logical. Okay. On every disk, whether it is hard disk or flash disk, okay, hard disk or flash disk, Exadata storage server creates something called as cell disk. Okay, and in fact, every hard disk or every flash disk is automatically detected by the storage server as a LUN. Okay, LUN. LUN is the storage term, right? Logical unit number or logical unit. So you have 12 hard disks. That means at Exadata storage level, you have 12 LUNs. Then you have 16 flash disks. Okay, that means at Exadata storage server level, you have 16 LUNs, right? On every LUN, we create a cell disk. Okay? We create cell disk. Cell disk is a logical disk created on every physical disk and every flash disk. Cell disks are created, okay, cell disks created on the physical disks are named as CD. Okay, the disk number 01, 00, 01 up to 011 and cell name. So this is the standard naming convention used for cell disks, right? Then cell disks created on the flash disks are named as FD. Again, the same convention. So if the cell disk name is starting with the CD, it is created on the hard disk. If the cell disk the name is starting with FD, it means it is created on the flash disk. Okay. So that is the mapping. You have hard disk. Every hard disk is detected inside the storage server as a LUN. On a LUN, we create cell disk. And next, on a cell disk, we create grid disks. Okay. So grid disk is again a logical disk created on a cell disk. And on one cell disk, you can create multiple grid disks. Okay. Again, how many grid disks you will create depends on how many ASM disk groups you are going to create ultimately. Okay. So can be created on, these grid disks can be created on hard disk based cell disks or flash disk based cell disks. Okay. So next you have ASM disk, and ASM disk is nothing but a grid disk in Exadata storage server, which is, okay, every grid disk is visible to ASM as an ASM disk. And you know, grid disk is used to create ASM disk groups. And once you create a disk group, your storage clients like database clients can use the ASM disk groups to store the data. Okay. So this is the hierarchy of the objects in Exadata. You have hard disk or flash disk. On a hard disk, we create a cell disk, or on flash disk, we create a cell disk. And once a cell disk is created, we create grid disks on the cell disk. And these grid disks are visible to ASM as ASM disks. Okay. So let us understand more about these disks in Exadata. So if you see the storage server, every storage server has 12 disks exactly, right? 12 hard disks. Now this diagram shows you the disk layout on the storage server. You have 12 disks, disk 0, disk 1, disk 2, disk 3, so on, disk 11. Now if you see the layout of the disks, the first two disks, on the first two disks in every storage server, there is some portion called as system area. Okay, some of the disk space is reserved and called as system area. So this system area is used to install operating system binaries, shell software binaries, and to store alert and metric repository. And this size is 29.125 GB, approximately 29 GB. Okay, so on the first 2 days, 29 GB is reserved for operating system binaries, shell software binaries, and alert and metric repository. the same amount of space, okay, is used for DBFS DG on the remaining 10 disks. Okay, so on the remaining 10 disks, again the same amount of space, that is 29.125, is used to create a disk group called DBFS DG. Okay, so we have a concept called DBFS. So in Exadata, by default DBFS is implemented. Okay, so for that this space is used. Okay, so we'll learn more about DBFS at a very later stage. Okay, at that time you will appreciate why, okay, this space is reserved. So now once this is done, every disk has the same amount of free space, right? The same amount of free space. Now let us see how the initial installation and configuration uses this free space. Okay. During the initial installation and configuration, Oracle uses a utility called one command utility to install and configure Exadata. And one command utility automates the installation and the configuration of the Exadata database machine. So the one command utility, okay, creates two grid disks on this free space. Okay, one is, okay, named in the form of data, second is named in the form of reco. Okay, because ultimately the entire storage is used to configure three disk groups. Okay, one is DBFS DG, second is data, third is reco. Okay, so for DBFS DG, 29 GB is used. Out of the remaining space, 40% is used for data DG, 60% is used for fast recovery area, that is reco, named as reco. Okay, so the one command process creates three grid disks on each disk. One is used for DBFS DG and this grid disk size is 29 GB. The remaining free space is split into 40-60 ratio. 40 is going into data, 60 is going into reco. So with this formatting, every disk inside the storage server has three grid disks, okay, as shown in this slide, and it is same on every storage server. Okay, so by default the split is like this only. Again, there is another split that can be done by one command process. Instead of 42 data, it can assign 82 data, 22 reco. Okay, 22 reco. So we'll see this in the next topic, Y40, Y60, or Y80, Y20 and all that. Okay, for now all that you need to understand is on the real Exadata box, every hard disk, okay, on every hard disk Oracle creates one cell disk, and on every cell disk there are three grid disks created. Okay, now this is what I was telling you, the storage objects and their relations. At operating system level, at a hardware level, you have a disk, right? So this disk can be hard disk or flash disk. Now inside storage server, every hard disk or flash disk is detected as a LUN, and on the LUN we create a cell disk. Okay, up to this there is one-to-one mapping. Every disk is mapped to a LUN. Every LUN we create a cell disk. Now once a cell disk is created, right, you create grid disks on the cell disks, and you can create a multiple number of grid disks. And each grid disk is treated as an ASM disk. So once you create the grid disks are visible inside the ASM as an ASM disk. Okay, so that is how you provision the storage for Exadata. You add the hard disk to the storage server. It is detected as LUN. On LUN, you need to create a cell disk. On cell disk, you need to create grid disks. Then these grid disks are visible inside ASM as ASM disk. So once ASM disk is visible, you can create ASM disk groups. And ASM clients can use this disk group to store data.
Okay.
So in other, yeah, please go ahead.
Yeah. So this is you know, the lower level, the physical disk is, I mean, if I understood, disk is representing a physical disk, whether it is a flash or a physical, I mean, a regular disk, right?
Correct.
So that means at the end state, is it going to be like a disk equivalent to, you know, in a normal storage, I can carve out a LUN. I mean, I can carve out LUNs, meaning nothing but a partition.
Yeah.
Multiple LUNs on a single disk or a bunch of, you know, RAID disk, right? So here, is it going to be one disk, one ASM disk, or one disk can be created as multiple LUNs and those can be added as different disks to ASM level?
Here, one disk is treated as one LUN. One physical disk is treated as one LUN. And
so, go ahead.
On a LUN, we create a cell disk. Again, one LUN is equivalent to one cell disk, right? And on a cell disk, you can create multiple grid disks.
Oh, okay. That part I missed. Okay. Now from the grid disk, I would convert into a regular way, like you know, each grid disk is a LUN, and I can add to different ASM disk groups, right?
Correct. Each grid disk can be part of different disk groups.
Great. Okay. Got it. Thank you.
So these dotted things are within the storage server. Okay. So if you see, these objects are within the storage server layer. Disk is at OS level, at hardware level. Then again, ASM disk is within ASM. Okay. So these three are your storage server objects, logical abstraction of the physical disk. So in other words, this is another representation of the same fact. You have physical disks which are treated as a LUN, right? On that we create a cell disk, and on a cell disk we create a grid disk, and each grid disk, okay, on a cell disk you can create a single grid disk or multiple grid disks, and each disk grid disk is treated as an ASM disk, and with that you can create ASM disk group. So ultimately each grid disk is consumed inside the ASM disk group. Okay.
So Murali, so with this, I mean, maybe you are going to cover, but you know, stop me if it is going to cover.
Yeah.
So here, do we have to enable the redundancy at the ASN level, or the actual LUNs also in the Exadata can be raided?
No, these LUNs are hard disks, doesn't have RAID actually. Okay, inside the storage server. So when you create disk groups, ASM disk groups,
then I need to go redundancy. Right.
redundancy, you need to mention the redundancy, correct.
Got it.
Yeah.
Okay, thank you.
So now, actually, this is hard disk, the relation. Okay, let me be very specific. I'm sorry, I'm modifying during the class itself. I should have done this before. To bring in more clarity, I am doing these changes on the fly. Now, the disk can be hard disk or flash disk, right? So when you use a hard disk, this is the hierarchy of the objects. Every hard disk is detected as a LUN inside the storage server. On every LUN, we create a cell disk. There is create a cell disk command. Okay, so with that we create cell disk. Then on every cell disk, you can create a multiple number of grid disks or a single grid disk. Once a grid disk is created, it is exposed to ASM as an ASM disk. So within ASM, you create ASM disk groups utilizing all these grid disks. So that is how the disk space is provisioned. Now, instead of hard disk, you may use a flash disk also, right? You may use flash disk or flash storage. So in that case, how this flash disk or flash storage is used? Because Oracle can use flash storage in different ways. Okay, hard disk is ultimately used as an ASM disk to create ASM disk groups. Now when it comes to flash storage, again every flash disk is exposed to storage server, Exadata storage server as a LUN. On the LUN again we create cell disk. Now this cell disk can be used in two different ways. One is the regular on a cell disk we create grid disk, and this grid disk is exposed to ASM as ASM disk, and you can use it to create ASM disk groups to store your data. Okay, but Oracle doesn't do this by default. Instead, all the flash storage is configured as flash cache and flash log. Okay, so that means on the flash storage, Oracle doesn't create any grid disks, and Oracle will not use it to create ASM disk groups. Instead, there are two features in Exadata storage server called as Smart Flash Cache, Smart Flash Log. Okay, so by default, the flash storage is used to implement these two features. Okay, so that is the concept. If you don't want to use these features, you can use the flash storage to create grid disks and then use these grid disks to create ASM disk groups to store your data. But by default, the initial one command process configures all the flash storage as flash cache and flash log. That means you will not have any grid disks based on the flash storage. You will have grid disks based on the hard disk only. But anytime you can drop the flash cache and flash log and use the flash storage to create grid disks. In the lab, we are going to do all these things. Okay, by default again I implemented flash cache and flash log in the lab. You will break that. You will create grid disks on the flash storage and create ASM disk groups. Again you will break them and again implement a flash cache and flash log. So all these things okay, we are going to practically implement in the lab. Okay. So that is the concept. I know initially it will be a little bit confusing because traditionally we are used to database related things, but these are purely storage related concepts which may be confusing at times. Okay. Again, another representation. You have flash based LUN on which we create cell disk, and this cell disk can be used for two purposes: to create a grid disk or to create flash cache and a flash log. Okay. So if you want, you can implement both. Some storage can be used to create a grid disk, and the remaining space, the remaining storage can be used to implement a flash cache and a flash log. So it is very flexible when it comes to flash storage. But by default, the entire flash storage available is used to configure flash cache and a flash log. There are no grid disks created on the flash storage. If you want, you can create them and use to store your data. Is this clear or any confusion?
So for the let's say we go with the flash cache and flash log. Yeah. So the way how it is going to be used by the database, is that specialty of the Exadata?
Yes, actually, flash cache and flash log are unique features of Exadata.
Got it.
Okay, but nowadays the other storage servers also implementing similar features. Like flash cache is present in many storage servers nowadays. But the way that flash cache works is very different from the way Exadata flash cache works. Okay, Exadata flash cache is more intelligent. Okay, and that way it is very different from the flash cache concept in third-party storage servers. We'll see. We have dedicated topics for flash cache and flash log. So at that time we will see more details and what is that intelligence compared to other storage servers. Okay. So can I move forward, or anybody has confusion? You want me to repeat this once again? I can do that. But this concept is very, very important for you. The entire foundation is laid on these concepts. Don't hesitate. Okay. If you did not understand this, feel free to ask me. I can repeat this a number of times if you want. Okay. So if no issue, then we'll move forward. But still, if you has any confusion at a later stage also, feel free tomorrow, day after tomorrow, anytime you ask me. I can repeat this topic if required. Now, this slide shows you with a little bit animation. Now in this slide, we have two storage servers, also called as cells, Exadata cell, Exadata cell. For simplicity, each cell has 3 disks shown in this diagram. In real time, you have 12 disks, right? Now you have your database server accessing the storage servers, and the storage server manages the disks. Now each disk, each hard disk or each flash disk is treated as a cell disk, right? So ultimately, the hard disk or flash disk is treated as a cell disk inside the Exadata storage server. Cell disk is the entity that represents a physical disk residing within the Exadata storage cell. Okay, and hard disk is automatically detected and discovered and activated as a LUN inside the storage server. And on the LUN, we need to create a cell disk. There are commands to create a cell disk and to create a grid disk. Okay. Next, grid disk. Okay. Now, once the cell disk is created, on the cell disk, we create a grid disk like this. On a cell disk, you can create a multiple number of grid disks. So this slide is showing you, okay, two grid disks. Red portion is one grid disk, blue portion is another grid disk. So on every disk and on every cell, this is done. Okay. Cell disks are logically partitioned into grid disks. Cell disks are logically partitioned into grid disks. How many grid disks? It depends on how many ASM disk groups you are going to implement on this storage. Suppose at ASM level, ultimately you are going to create two disk groups. Then on every cell disk, you create two grid disks only. Or suppose you are going to create 4 ASM disk groups. Then on every cell disk, you will create 4 grid disks. So ultimately it is driven by how many ASM disk groups you are going to create at the storage level. And on the real Exadata, the entire storage is used to configure 3 ASM disk groups: DBFSDG, data, reco. Data under reco is used for database storage. Data stores database files, CRD files. Reco stores recovery related files like backups, archive log files, flash log files. DBFSDG is used to implement a feature called DBFS, database file system. Okay. So that way the storage is divided into 3 disk groups. Grid disk is the entity allocated to ASM as an ASM disk. Minimum of 1 grid disk per cell disk. So on a cell disk, a minimum of 1 grid disk has to be created, and you can create multiple grid disks. Next, this is what you are referring to, Sai, mirroring. Okay, redundancy. So once ASM disks are available, once the grid disks are created, each grid disk is treated as an ASM disk, and we use these grid disks to create ASM disk groups. For example, in this slide, the red portion is a grid disk. Each red portion is a grid disk, nothing but ASM disk. So we use all these grid disks to create ASM disk group. Okay. ASM striping evenly distributes I/O across the disk group. So ASM has inbuilt striping mechanism. So the data will be striped across all the disks inside the disk group. Right? Then ASM mirroring is used to protect against disk failures or cell failures. So the mirroring is implemented at the ASM level. There is no hardware level RAID implemented inside the storage server. Now, for example, you see this slide. Now, once ASM disk group is created, Exadata automatically creates failure groups inside each disk group. And all the grid disks belonging to a particular cell will be in one failure group. So that even if the entire cell fails, you have the data accessible. So your database will not have any impact even if the entire cell has a failure. So all the grid disks coming from a particular cell will be in one failure group. So now you have two cells, right? When you create the disk group, it will have two failure groups. The grid disks coming from the first cell will be in one failure group. The grid disks coming from another cell will be in a different failure group. Now we know ASM uses failure groups to place the mirror extent, right? Mirror extent will always be placed in a different failure groups, so that the failure of all the disks in the failure group can be tolerated. The simultaneous failure of the disks in a failure group can be tolerated. So that is how failure groups are implemented inside the Exadata. So this is very, very important concept to understand the high availability of Exadata. The same in another representation. Any doubts on this part?
I'm good.
Yeah. So this is same representation. Now, when it comes to Exadata, there are some auto disk management features inside Exadata. Okay, these features are not available on non-Exadata platforms. So what are those auto disk management concepts? Now, whenever a grid disk status is changed to offline, the corresponding ASM disk is taken to offline inside ASM. Okay, at storage level, if you offline a grid disk, at ASM level, that ASM disk is automatically offlined by ASM. So you don't need to manually offline it inside ASM. Then again, in the storage level, inside the storage server, if you bring that grid disk online, and it is automatically online inside ASM. You don't need to manually do that. That is one automation built into Exadata. Second automation is inside the storage server, you can activate, inactivate the grid disk. So whenever you inactivate a grid disk inside the storage server, the corresponding ASM disk will be automatically offlined inside ASM. You don't need to manually do that. Once again, whenever you activate that grid disk inside the storage server, the corresponding ASM disk will be onlined automatically inside ASM. Okay. Then the third automation is, if a disk fails, this is one of the common failure in real time also. Whenever a disk fails, you will replace that disk, right, with the new disk. And once you attach the new disk, Exadata storage server automatically creates a cell disk, automatically create grid disks, and these grid disks are automatically added to the disk group. without any intervention from the user. Okay. So that way, whenever a hard disk fails, it is very simple. Just replace it. Let everything happen automatically. Okay. So these are some auto disk management features available only on Exadata platform. And we have a lab exercise to practically verify all these things actually. Okay. So it will be tested in our lab also. Now to implement all these automatic features, there are two additional background processes added to ASM instance in the form of XDMG, which is the manager process, okay, and XDWK, which is the worker process. So these two processes implements all these auto disk management features on Exadata platform. So this is some concept related to the storage server. Just a conceptual overview. Okay, later we will see the administration part of the storage server. So that's it for today. Any doubts on today's class? If no doubts, I will show you the demos that you can start and practice up to now. So whatever we covered so far, slowly becoming complicated. Yes, that is natural and normal, right? Because we are going deep into the subject, right? But I will try to make it as simple as possible. You also put your full 100% attention and concentration when I am explaining, and feel free to ask okay, any doubt or any clarification, or if you did not understand any concept, you have to come forward and utilize that opportunity. So you can easily practice up to 7. Okay, whatever we discussed covers all these practices, and every practice has step-by-step okay, guide. You just execute those commands, observe the output, try to correlate and understand how it is working inside the machine. Let me see some, in which case we can use these flash cache and flash log for database. Okay. See, this flash cache and flash log are unique features of Exadata. Flash cache caches frequently accessed data inside the storage server. Okay. And the flash log is used by your log writer to write a redo log data. Okay. So using flash cache and the flash log, your IO performance is improved a lot. Okay. Without them also, you can run the database machine, but when you implement a flash cache and a flash log, your IO performance is much better. Okay. So just to wait for a few more classes, we will come to flash cache, flash log topic, then we will discuss at length what are those and benefits of flash cache and flash log. Yeah, certification, Exadata certification, basically you have only, nowadays it is only one certification, sorry. Okay. If you want, I can show you some slide related to certification. Anyway, that comes at the end of the course, but you may plan early if you know the things. Basically, now even though we are talking about the latest version, which is X6, certification is available up to X5 version only. Okay, but you are learning the latest version X6. Any reference I make is related to X6 version. So with that, you should be able to create clear previous certification also. So basically, there are two certifications for X3 and X4 and for X5. Okay, and this is expert certificate, only one certificate. Now, if you want to go for X5 version certificate, which is the latest available certificate, its exam code is 1Z0070. Okay, and this is still in beta. Actually, X5 is still in beta. Okay, and its price as of now in Indian rupees is 3,500, 3,300 only. It is very less because it is still in beta. But if you want to go for X3, X4 based certification, the price is 10,000 rupees. Okay, and you will have 150 minutes time and 90 questions are all multiple choice only. So very simple, only one certificate, X3, X4 based certificate or X5 based certificate. X5 is still in beta. So if you want more details, this is the URL. You can explore in terms of USD and all that. You can show you education.oracle.com/certification. Okay. Sai, is it clear? You got the details?
Yeah, Marley. Yeah. I don't think there is any prerequisite to have the Oracle instructor-led or
Right.
Oracle course, right?
Luckily, as of now, there is no such a requirement.
Yeah, that's good.
Yeah, before you put such thing, you better go for certification if you are planning.
Yeah. And if you can, I posted 2 questions. So just look into if you can either, give me, if you want to talk, I can give you a call, or, if you can reply to my email.
Yeah, see, once you log into Oracle Cloud, right, e-delivery platform, you type Exa here just. Okay. You can search with Exa, then it will show you many things. Okay, Exa related products. Now if you come down, it will show you Exadata storage server software. This is the latest and the greatest. Okay, so you can choose any release and download that.
Okay.
So in the lab, I am using this 112321. I'm trying to compile 12 based this thing, but there are many issues in 12C related thing, especially in the lab environment. Maybe on the real hardware it might be smooth, but in the lab it is becoming challenge.
Okay, and is there installation steps that you can share for me to go ahead and I've already got the virtual boxes and VMware version running. So I can use the VirtualBox, Oracle VirtualBox.
Yeah.
So yeah, if you can send me some kind of high level.
I will send you some link. There are some sites which will talk about the step-by-step process. Okay.
Sure.
As such, I don't have any documented procedure because I know this procedure for quite long time, but I don't have specific document. But I can share that link with you. You can find the step-by-step process there. And if you face any problem, I will be there for you.
Great. Yeah, that'll be great.
Yeah.
And the final question, I need to talk to you. The one I'm very serious about it. So either I can give you a call or whichever.
Okay, that is related to rack and Golden Gate, right?
Yeah.
Okay. See, Rack and Golden Gate, we have standard course actually. You can go through our website, download the brochures and see the course topics. But if you are looking something beyond that, we need to discuss.
Yeah, that's what I'm saying. I mean, I'm looking into probably, if you talk, then you'll know what I'm looking for. So let me,
Maybe can we talk in the evening? I need to rush to office
sure,
now.
no problem, no
Okay.
problem. Yeah,
Evening we can talk, no problem. That is your
yeah,
morning.
yeah, no problem. Sounds good.
Yeah. Thank you.
Thank you. No problem. Bye.
Others, any more questions?
Murli Praveen.
Yeah, Praveen.
Yeah, regarding the cell disk, out of cell disk, we make the ASM disk, right?
Yeah, on every cell disk, you create a grid disk. Grid disk
Grid
is
disk, sir.
nothing but your ASM disk.
Yeah. So you mentioned that there is no hardware redundancy.
Yeah.
So we implemented the software. So for every disk group, there is if you go for redundancy, there will be a failure group.
Right, exactly. So the
So
redundancy is implemented inside ASM.
so actual group is on one LAN and fail group is on another LAN.
It is not a LUN actually. The failure group at cell level actually. All the grid disks belonging to one cell will be in one failure group.
Okay.
Okay, suppose all the grid disks from first cell will be in one failure group, and all the grid disks from the second cell will be in a different failure groups.
Okay.
So for every cell there is a failure group.
Okay. What I mean to ask is if both failure group and actual group, if they fail at the same time, how do you ensure high availability? Is it through RAC?
It is no storage level failures. Okay, are taken care with ASM redundancy. So when you create a
Okay.
disk group, you need to mention normal redundancy or high redundancy.
Yeah.
Based on
Yeah.
that, your ASM extents will be mirrored. Okay, by side. Okay,
Okay.
and node level, database server level failures are taken care with RAC. If one node fails, you will have another node and another instance.
Okay.
That way.
Okay.
Yeah.
Okay.
Murali is Gangadhar.
Yeah, Gangadhar.
So don't we have in Exadata the external redundancy by any chance?
No, on Exadata you cannot use external redundancy. Okay, because there is no hardware level RAID implemented.
Okay. If suppose a cell fails, then only the fail group will take care, or what will happen to that particular cell? Maybe the failure group will have the data.
Correct, right. See, you have other cells, right? You have other cells.
Yeah.
The mirror extents will be on other cells. So that way you have data available to you without any problem.
Yeah. Suppose a cell fails in the one fail group, and the data which is on that particular cell will be lost permanently, and because the failure group is available, but how we are retrieving the data particular cell which has got lost?
No. See, if the cell is lost, for that data on that cell, you have mirror data on the different cell.
Yeah.
So ASM will read that mirror data now.
Okay. And we will replace the whole the failure cell, right?
Right. After that, you have to replace the cell, failed cell, or fix that issue. Then once again, it will build the redundancy from the mirror copies.
Okay, so automatically from the failed group, it will come it back?
Yes, it will automatically build that mirror copy again once you add that cell back.
Okay. And what is the minimum? That means we need to have this redundancy level normal or high? What is the basic?
You can use, see, for mission critical applications, Oracle recommends high.
Okay.
Otherwise, you can go with the normal. But what you need to understand is the effective usable space will reduce with the high redundancy, right?
Yeah.
So that is another point you need to be aware.
Okay.
High is recommended for mission critical systems, otherwise normal.
When we have the machine, Exadata machine with flash storage and hard disk both, then how we can utilize this flash and physical? That means in which cases we can use the flash and in which cases we use the ASM.
Yeah, you can see, as I told you earlier, by default, flash storage is configured as flash cache and flash log. Okay, to improve your I/O performance. Or you can use flash storage to create ASM disk groups and to store data. Or you can use for both purpose. Some flash can be used to create ASM disk groups. The remaining flash can be used to implement flash cache and flash log.
Okay. And do we have any more speed R balance for this particular ASM? Normally it's 0 to 11, right? And
no, that is same. That is same on Exadata also, because it is not Exadata feature, it is ASM feature.
Yeah.
It is same.
Okay. Because we have flash storage, right? Suppose it will then it will be more speed, right? That's right.
No, if it is on the flash storage, the rebalancing happens quickly because of the performance. Flash storage is high performing storage, right? So your rebalance may complete in quick time.
Okay.
Yep.
Murli, suppose can it withstand the two cell failures?
Yeah.
One cell is failed and also failure group cell is also failed.
If you implement high redundancy, it can withstand two simultaneous failures of the cell.
Okay, in the normal case it is not possible.
In normal, only one cell failure can be tolerated.
Oh, okay.
So if both fail, automatically it will fail out to the disaster recovery area?
No, DR, you are talking about standby?
Yeah, that's right. Because if we have two failed groups and both are failed,
then you have to actually, you should have implemented a DR, okay, the standby database. So once the primary storage fails, the primary site storage failure, you need to trigger failover, right, to the DR. So that has to be implemented. Without DR, this is not possible, right? So if you want to tolerate storage failures, total storage failures, you should have implemented a DR.
Yeah, because of the catastrophic failure sometimes,
yes,
maybe the site will not.
Correct. So any disaster, you should have implemented a data guard.
Okay, got it. Thank you.
Yeah. Okay, so that's good. Okay, healthy discussions are happening. More questions are coming, and feel free to ask questions like this. I love questions. Okay, That is where you keep me on my toes also. Okay, thank you for today. We'll continue in tomorrow's session. Bye-bye.
Bye.
Bye.